Hey, space enthusiasts! Today, we're diving into one of the most exciting milestones in space exploration. NASA's Parker Solar Probe is making history by becoming the first spacecraft to touch the Sun. What does that even mean, and what incredible discoveries have been made? Stick around, because we're about to explore this groundbreaking mission and the mind-blowing insights it's giving us about our closest star. NASA launched the Parker Solar Probe back in 2018 with one goal in mind: to get up close and personal with the Sun. Its mission is unprecedented, designed to fly directly into the Sun's corona, the outermost part of its atmosphere. Why is this important? Well, the corona is where solar winds and magnetic fields originate, and these forces have massive effects on our solar system, including Earth. The Parker Solar Probe is equipped with advanced instruments to measure magnetic fields, solar winds, and plasma as it zooms through this intense environment. It's traveling at mind-boggling speeds up to 430,000 miles per hour. That's fast enough to circle the Earth 13 times in just 1 hour. You've probably heard that the Parker Solar Probe touched the Sun. But what does that really mean? In December 2021, the spacecraft crossed the Alpha-N critical surface, a boundary where solar wind transitions from being bound to the Sun's magnetic field to flowing freely through space. Crossing this boundary is what scientists define as touching the Sun. It's a monumental achievement because it means the spacecraft has entered a region where no human-made object has ever been. This data is helping us understand how solar winds are accelerated and how energy flows in the Sun's atmosphere, shedding light on some of the biggest mysteries of solar physics. Since crossing the Alpha-N critical surface, the Parker Solar Probe has already uncovered some incredible discoveries. One of the most significant findings is about the solar wind itself. The data shows that solar winds are not as uniform as we once thought. There are switchbacks, zigzag patterns in the magnetic fields that could explain why the solar wind accelerates as it moves away from the Sun. Additionally, the probe has provided crucial information about solar flares, which are bursts of energy that can disrupt communications and power grids here on Earth. Understanding how and why these flares occur will help us protect our technology in the future. Flying into the Sun's corona isn't a walk in the park. The Parker Solar Probe had to be designed to withstand extreme temperatures up to 2,000 degrees Fahrenheit. How does it do that? The spacecraft is equipped with a cutting-edge heat shield made of carbon composite material that protects its delicate instruments. It also uses an autonomous system to adjust its position, ensuring that the shield is always facing the Sun. This high-tech engineering marvel allows the probe to continue functioning in an environment that would destroy most spacecraft. It's a testament to human ingenuity and our relentless pursuit of knowledge. You might be wondering, why should we care about the Parker Solar Probe's mission? Well, it's not just about exploring space for fun. Understanding the Sun is crucial for life on Earth. The Sun's activity, like solar winds and flares, can have a direct impact on our planet. For instance, solar storms can knock out satellites, GPS systems, and even power grids. The data gathered by the Parker Solar Probe is helping scientists predict solar activity more accurately, which could give us time to prepare and mitigate the effects of space weather on our technology. In short, this mission is about protecting our modern way of life while pushing the boundaries of human knowledge. The Sun is the heart of our solar system, providing energy for life on Earth and driving weather patterns in space. But while we've observed it from afar for centuries, there's still so much we don't know. The Parker Solar Probe is helping scientists understand the complex and turbulent processes happening within the Sun, from solar winds to the magnetic fields that stretch out across the solar system. Everything is connected to the Sun's dynamic energy. And the more we learn about it, the better we can understand the forces that shape our environment here on Earth. The Parker Solar Probe is no ordinary spacecraft. Building something that could survive the Sun's intense heat and radiation required cutting-edge technology. One of the key features is its heat shield, which is made from a special carbon composite material designed to withstand temperatures of up to 2,000 degrees Fahrenheit. This shield is just 4.5 inches thick, but protects the sensitive instruments on board from the searing heat. Additionally, the spacecraft's solar panels are engineered to cool themselves as they get closer to the sun, ensuring the probe has enough power to operate without overheating. Solar flares are one of the most dangerous aspects of the sun's activity. These sudden bursts of energy can eject billions of tons of solar material into space, creating solar storms. When these storms hit Earth, they can cause major disruptions, especially to communication systems and power grids. The Parker Solar Probe is helping scientists understand how and why solar flares happen, which is crucial for predicting when they might occur. Better predictions mean we can prepare for solar storms and minimize their impact on modern technology. One of the biggest mysteries the Parker Solar Probe is helping to solve is the source of solar winds. Solar winds are streams of charged particles that flow out from the sun at high speeds. While we've known about solar winds for decades, their origins were unclear. By flying into the sun's corona, the probe has revealed that solar winds come from structures in the sun's atmosphere called coronal holes. These are cooler, less dense areas where magnetic fields allow solar winds to escape at high speeds, fueling the winds that flow across the solar system. Magnetic fields play a critical role in controlling solar activity, and the Parker Solar Probe is giving us unprecedented insight into how they work. Magnetic fields are responsible for shaping the sun's atmosphere and driving processes like solar winds and flares. The probe's instruments measure these fields as they fluctuate and change, providing data that helps us understand the sun's magnetic dynamics. This information is key to solving long-standing puzzles about how energy moves through the sun's atmosphere and affects space weather. A surprising discovery from the Parker Solar Probe is the phenomenon of switchbacks in the sun's magnetic field. These are sharp, zigzag patterns that occur in solar winds, causing the direction of the magnetic field to flip rapidly. Scientists believe these switchbacks may help explain how solar winds accelerate as they move away from the sun. This new insight could reshape our understanding of solar winds and their impact on the solar system, particularly on Earth's magnetic field and climate. Plasma, the fourth state of matter, is what makes up the sun and the solar wind. The Parker Solar Probe is studying the properties of plasma in extreme conditions, providing a wealth of data on how it behaves under the influence of magnetic fields and solar energy. This is critical because plasma is not only found in the sun, but throughout the universe, from stars to the vast regions between galaxies. By understanding how plasma works in the sun, we gain insights into processes happening on a cosmic scale. Space weather forecasting is becoming increasingly important as we rely more on technology that is vulnerable to solar activity. The Parker Solar Probe's data is helping improve our ability to predict space weather by giving scientists a closer look at how solar winds and magnetic fields interact. By understanding the conditions that lead to solar storms and flares, we can better anticipate their effects on satellites, power grids, and even astronauts aboard space stations. It's a critical step toward safeguarding our technology from space hazards. The Parker Solar Probe is on a mission to get closer to the sun than any spacecraft before. Over the course of its 7-year mission, it will make multiple passes by the sun, each time getting closer. By the end of its journey, it will be just 3.83 million miles away from the sun's surface. To put that in perspective, Earth is about 93 million miles from the sun. This proximity will allow the probe to gather data from the hottest and most energetic parts of the sun's atmosphere. You might be surprised to learn that Venus plays a key role in the Parker Solar Probe's mission. The spacecraft uses Venus's gravity to adjust its trajectory and speed as it makes its way closer to the sun. These gravity assists allow the probe to get closer with each pass, without using additional fuel. In fact, the Parker Solar Probe will make 7 flybys of Venus throughout its mission, each one bringing it closer to the sun. The solar wind has a significant impact on Earth's magnetosphere, the magnetic field that protects our planet from space weather. When solar winds interact with the magnetosphere, they can cause disturbances, including geomagnetic storms. These storms can affect communication systems, GPS, and even power grids. The Parker Solar Probe is helping us understand these interactions in greater detail, which will help us predict when and how solar winds might impact Earth. The Sun goes through an 11-year cycle of solar activity, alternating between periods of high and low solar activity. The Parker Solar Probe is providing valuable data that will help scientists understand these cycles and predict the next peaks in solar activity. During periods of high solar activity, solar flares and storms are more frequent, which can have a greater impact on Earth. By learning more about these cycles, we can prepare for periods of intense solar activity. The Parker Solar Probe is just the beginning of a new era in solar exploration. As we gather more data from the Sun, future missions could build on these discoveries, leading to even more advanced spacecraft and instruments. The next generation of solar probes could explore deeper into the Sun's atmosphere, unlocking more of its mysteries. The Parker Solar Probe is laying the groundwork for future solar exploration that could revolutionize our understanding of stars and space weather. The Parker Solar Probe isn't working alone. It's part of a larger network of space missions designed to study the Sun and space weather. ENASA's Solar and Heliospheric Observatory, SOHO, and the European Space Agency's Solar Orbiter are also gathering data on solar activity. Together, these missions are providing a comprehensive picture of how the Sun works and its impact on the solar system. This collaborative approach allows scientists to compare data from different perspectives and gain a deeper understanding of solar processes. When the Parker Solar Probe's mission concludes, its legacy will live on through the wealth of data it has collected. This information will continue to be analyzed by scientists for decades, leading to new discoveries and insights about the Sun. The probe is also inspiring future generations of scientists and engineers who will build on its success. Its mission is a testament to human curiosity and the drive to explore the unknown, and it will stand as one of the greatest achievements in space exploration. The Sun's corona is one of the most mysterious parts of the star. It's much hotter than the Sun's surface, with temperatures reaching millions of degrees. But why is the corona so hot? This has puzzled scientists for decades. The Parker Solar Probe is providing invaluable data on this phenomenon by flying directly through the corona and collecting information on its temperature, density, and energy transfer processes. Solving this mystery could unlock new understandings of other stars and their outer atmospheres as well. Solar storms, caused by flares and coronal mass ejections, CMEs, can have a significant impact on our communication systems. These storms can disrupt satellite signals, GPS, and even radio communications. By studying the behavior of the Sun and the conditions that lead to solar storms, the Parker Solar Probe is helping scientists predict when these events might occur. Early warnings allow us to take preventive measures to protect our critical infrastructure from the effects of space weather, ensuring that global communications continue without interruption. One fascinating aspect of the Parker Solar Probe's mission is its contribution to understanding the Sun's rotation. The Sun doesn't rotate as a solid body. Its equator spins faster than its poles, creating a complex system of rotating plasma and magnetic fields. The data collected by the Parker Solar Probe helps scientists study how this differential rotation affects the Sun's magnetic fields and contributes to solar phenomena like flares and sunspots. Understanding the Sun's rotation is key to predicting solar cycles and periods of intense activity. As we prepare for longer missions to the Moon and Mars, protecting astronauts from the harmful effects of space weather becomes critical. Solar storms can release intense bursts of radiation that pose significant health risks to astronauts. The Parker Solar Probe's mission is helping scientists understand how solar radiation behaves and how we can better predict dangerous solar events. This knowledge will inform the development of protective measures, such as radiation shields and early warning systems, to ensure the safety of future space explorers. Crossing the ALF-N critical surface was a monumental moment in space exploration. This boundary, where the solar wind transitions from subsonic to supersonic, represents a point where the sun's magnetic influence weakens, and solar winds begin flowing freely through space. By crossing this threshold, the Parker Solar Probe has ventured into uncharted territory, allowing scientists to observe the origins of solar wind up close. Understanding this boundary is crucial for modeling how energy and particles are transferred from the sun to the solar system. Another mystery the Parker Solar Probe is shedding light on is why the sun's atmosphere, or corona, extends far beyond its surface. The corona's reach spans millions of miles, but the mechanisms behind its expansion were not well understood. The probe's close encounters are helping scientists determine how energy is transferred from the sun's surface to its outer layers. The answers could help explain how stars in other systems behave and contribute to our broader understanding of stellar evolution. One of the greatest aspects of the Parker Solar Probe's mission is the open sharing of data. The information gathered is made available to scientists around the world, allowing experts in various fields to study and analyze the findings. This collaborative approach accelerates the pace of discovery, enabling breakthroughs in solar physics and space weather forecasting. The probe's contributions are enhancing our collective knowledge of the sun and encouraging international collaboration in space research. The design and engineering innovations used in the Parker Solar Probe are paving the way for the next generation of spacecraft. From its heat shield to its autonomous navigation system, the probe represents a technological leap in space exploration. Future missions, whether to other stars, planets, or moons, will likely incorporate these advancements. The lessons learned from this mission will inform the design of spacecraft that can withstand extreme environments, whether in close proximity to other stars or in the hostile atmospheres of distant planets. Coronal mass ejections, CMEs, are massive bursts of solar material and magnetic fields that are ejected from the sun's corona into space. When these CMEs reach Earth, they can disrupt satellites and power grids. The Parker Solar Probe is giving scientists a closer look at how these ejections form and how they interact with the solar wind. This knowledge will help us predict when CMEs are likely to occur and how they might affect Earth, enabling better preparedness and mitigation efforts. Solar winds are not just important for understanding space weather, they also play a role in space exploration itself. The interaction between solar winds and spacecraft, including future missions to Mars or deep space, needs to be carefully considered. The Parker Solar Probe is helping scientists understand how solar winds affect spacecraft propulsion and how we might use or counteract these forces in future missions. This could open new possibilities for navigating and powering spacecraft as they travel through the solar system. One unexpected area where the Parker Solar Probe could have an impact is solar energy technology. By studying the sun's energy output and how it interacts with its atmosphere, scientists could gain insights that lead to more efficient ways to harness solar energy here on Earth. Understanding solar radiation and its fluctuations can help improve the design of solar panels, leading to more reliable and sustainable energy solutions. The Parker Solar Probe is scheduled to complete its mission in 2025 after 7 years of orbiting the sun. During its final passes, the spacecraft will continue to get closer to the sun, gathering data right up until the end. Eventually, the intense heat and radiation will cause the spacecraft to disintegrate. But even as it perishes, the probe will have completed one of the most ambitious missions in the history of space exploration, leaving a lasting legacy of discovery. The Parker Solar Probe is equipped with 4 main instrument suites designed to study the sun's magnetic field, plasma, and energetic particles. These include the FEIALDS suite, which measures electric and magnetic fields, the WISPR imager, which captures images of solar structures, the SWEAP suite, which measures solar wind particles, and the ISIS suite, which detects energetic particles. Together, these instruments provide a comprehensive picture of the sun's activity and its influence on the solar system. The Parker Solar Probe is named after Dr. Eugene Parker, an astrophysicist who predicted the existence of the solar wind in 1958. This was a groundbreaking theory at the time, and his work laid the foundation for much of what we know about solar physics today. The probe is the first NASA mission named after a living person, honoring Dr. Parker's immense contributions to our understanding of the Sun and its influence on the solar system. Navigating a spacecraft close to the Sun requires an advanced system of course corrections and adjustments. The Parker Solar Probe uses a combination of onboard sensors and ground-based commands to stay on its planned trajectory. The spacecraft constantly monitors its position relative to the Sun and adjusts its flight path using tiny thrusters. This autonomous system ensures the spacecraft remains in the optimal position to gather data while keeping its heat shield facing the Sun for protection. Although the Parker Solar Probe doesn't observe solar eclipses, its data can enhance our understanding of these events. Solar eclipses provide a rare opportunity to observe the Sun's corona from Earth. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.